Okay, we're going to continue. I'm going to use double angle formulas to solve for x again. In this case, what I'm going to do is I'm going to solve for x, and we're going to only do on the interval. All right, so we're going to find solutions on interval from, let's go 0 to 2 pi. Okay, it makes it a little bit faster, more efficient. Okay, so we have this right here. Now, once again, we have 4 sine of x cosine of x equaling 1. Now, a lot of students will screw up on this because they'll divide by 4 the other side, and they'll make this 1/4, and they'll say sine of x cosine of x equals 1/4, and then they'll say, oh, this is when sine of x equals 1/4 and cosine of x equals 1/4. You can't do that. Sine of x equaling 1/4, no. And when cosine of x equals 1/4, no, that doesn't work out. You don't ever do that. I'm going to erase that. You don't want to do that because you only go through when you have 0 here. If that was 0, easy, we're happy. But this is not 0, this is actually 1. So what do we do? Well, this is very hard to solve without our calculator. And so what we can do instead is, if you notice, 4 sine of cosine x is very similar to 2 sine of cosine of x. And that is actually equal to sine of 2x. And so if we can take this and we rewrite this as 2 sine of x cosine of x equaling 1, we can use a little substitution and realize that this is actually a double angle. This is actually 2 sine of 2 theta, or in this case, x. And we are going to solve this when it equals 1. So now we're going to do, we have one single term. We're going to divide this by 2. Okay, so we have sine of 2x equals 1/2. We're then going to take 2x, take the inverse sine of both sides, and we have 1/2. And so now we're going to solve this. If we go over here, we realize that sine, one is sine positive. Sine is positive in the first and second quadrant right there. We're looking for our x value, and we have 1 and 2, and 1 and 2. And so that angle right there should equal 30 degrees, or, all right, pi over 6. And this is also 30 degrees as a reference angle. And so we're going to have a solution of 2x equals pi over 6. I'm going to put in here plus 2 pi n, plus 2 pi n. And then over here, we're going to have 2x equals 5 pi over 6, because that's the one in the third quadrant that we need, 6 plus 2 pi n. Now this goes back to how to solve trigonometric functions when you have a b value other than 1. All right, so if you realize this right here, our b value is greater than 1, so we might have multiple solutions here. This goes back to 10.3 if you're following along in my class, or how to solve trigonometric equations when you have multiple solutions. You can check out those videos if that is confusing to you. From here, we're going to divide by 2, and so what we have then is, moving on over there, that's going to be x is equal to, okay, pi over 12 plus pi n, because we divide by 2 both sides. And then we have this over here. We have x equaling, all right, 5 pi over 12 plus pi n. Well, now we have to figure out all of our solutions from, remember, I only want to figure out from 0, all right, to 2 pi, 0 to 2 pi. So from here, if we were done, okay, and we want to find all the solutions, that would be it. That would be our answer, okay? And we probably could put a minus there as well. However, since we're trying to find all, I changed this up and I said, okay, I want to find all the solutions from 0 to 2 pi. Okay, so I'm going to go when n equals 0, and n equals 1, and when n equals 2, and when n equals 3. And so we're going to figure this first one out. When n equals 0, we're going to have x equaling pi over 12, and then we'll have x equaling 5 pi over 12. When we have n equaling 1, we need a common denominator. So I'm going to put in 12 over 12. So we're going to have, this is going to be 13 pi over 12. And this is going to be right here, 12 plus 5 is 17 pi over 12. And how far are we going? If we go to 2, it's going to be 24. But if you recall, the highest we can go right here is 2 pi is actually equal to 24 pi over 12. And we're getting pretty close to that. If I go and put a 2 right there, that's going to be 24 plus 5 would be 25 pi over 12, which is past what I want. So we're not going to go any farther than that. And so these are our 4 solutions from, all right, 0 to 2 pi. These are all of our solutions. These are only our solutions from 0 to 2 pi. So depending on what you're doing, that's how we would solve it. Okay, so once again, using the Billinger formula, but we're kind of going in reverse, noticing that we can solve this really nicely. We see that we have sine and cosine. Oh yeah, that's sine of 2 theta. In this case, sine of 2x, and then we solve from there. Okay, well, we're going to have some more videos on this coming up in just a little bit.